So this question is about the reaction between lead nitrate and sodium iodide, forming sodium nitrate and lead 2 iodide. So a big hint here is the 2 and the 2 here tells you the charge on lead. So lead is Pb, is its symbol, and it is 2 plus. Now you should also know that iodide is just I minus, because it is in group 7. And nitrate is NO3 minus, and this is a polyatomic ion that you will need to remember. And we looked at this back in C1, C2. So basically using this, we know that lead is Pb2 plus, so if it's 2 plus, it's going to need 2 NO3s in order to be neutral. So we put an NO3, close brackets 2. That then tells us for every Pb that has a 2 plus, I have 2 NOs that have a minus, as shown there. This is then going to react with sodium iodide. Now sodium is in group 1, so it's going to be Na plus, and as we talked about up here, iodide is minus. This is then going to produce the two products, which is sodium nitrate, NaNO3, and this time Na is just a plus and NO3 is 1 minus, so therefore they're balanced. We don't need to change that. And then lead, because it is 2 plus and every iodide is a minus, I'm going to need 2 iodines. And because it's just on its own, there's just 1 iodine, so 1 atom, doesn't need a brackets around it, so we just put a 2 there. Now, I'm not going to show you how to balance this, but to be balanced, it's going to then need 2 NaIs, because basically I have 2 iodines here, so I need 2 iodines on this side. And then nitrates is also going to be 2, because the brackets here says there's 2 nitrates, so I need 2 nitrates here. And now that's balanced. So the next step in these calculations is we'll be told we've got 25 grams of lead nitrate, and we're reacting 15 grams of sodium iodide. How many moles do we have of each? So now we just work out number of moles using this equation here. So number of moles is mass given in the question divided by the molecular mass. So the mass for lead nitrate, we were told it's 25 grams of lead, so that goes there. And then lead to nitrate, which we know is the structure here, we're just adding up. So I've got Pb is 207. Now I've got to multiply everything in here by 2, because that's what this brackets is saying. So that's 2 is that there. Nitrogen is 14. I've got 3 oxygens within the bracket, so they're there. And then all of this together would add up to give 331. And if you put that into the calculator, you get 0.0755 moles. Again, don't be tempted to round up to 1 decimal place, 2 decimal places at this point. We do that at the very end. Same approach for sodium iodide. So the number of moles of sodium iodide, 15 grams divided by the molecular mass. Sodium is 23, iodine is 127. So the answer we get for that one, it roughly works out 0.1 moles, okay? So we're going to take these forward. So working out which is the limiting reagent. Now, obviously, reagent are the reactants. So we have this reactant here and this reactant here. So we're just going to compare the ratio of lead nitrate to sodium iodide. And we can see from the balanced equation that every 1 mole of lead nitrate will react with 2 moles of sodium iodide. So it's a 1 to 2 ratio, like so. Therefore, if we keep things simple, if whatever number of moles of lead nitrate I've worked out up here, which is 0.075, I would need twice the amount of moles in order for all of that to react, because 1 going to 2 is times 2. So if I input the number that we've worked out up here for lead nitrate, that is 0.0755. So that's for the lead nitrate. And then if I times that by 2, then what I am going to get is 0.151 moles that I would theoretically need of sodium iodide to react with this. However, have we got 0.151 moles from the mass that we're given? Well, if we look up here, we worked out from the number of moles of sodium iodide in 15 grams, we've only got 0.1 moles. We need 0.151, so our actual is less. So we know that NaI is the limiting reagent or reactant. And so lead nitrate must be the excess reactant. So now we've worked that out, we know that sodium iodide, the number of moles of this, 0.1 moles, is the actual we've got, is going to dictate how many moles of lead iodide that we produce. Now, we've got to look at the relationship between, in our balanced equation, sodium iodide and how that relates to lead iodide. So thinking of this as ratios, the sodium iodide, the limiting reagent, well, we have 2 moles in the balanced equation, so we are going to write a 2 down here. And then in our balanced equation, for every 2 moles of sodium iodide, it will give us 1 mole of lead iodide. So, we know that these are related together by divide by 2. And if we input the actual number of sodium iodide that we have, okay, which is 0.1, remember this value here of sodium iodide was theoretical that we would need to react with the excess lead nitrate. So it's this one here. So if we put that in, we've got 0.1. If I then divide, that's my sodium iodide that I actually have. If I divide that by 2, I know I am going to make 0.05 moles of lead iodide. Finally, how many grams of lead iodide? Well, up here we know the number of moles of lead iodide. And so we're going to go back to this equation here. We've got the number of moles. We can easily work out the MR of lead iodide, and then we can get the mass. So the mass of lead iodide is going to be 0.05 moles times the MR of lead iodide, which again, if we just put 207 for the lead, we've got 2 iodides, so that's 2 times 127. Add all that together, you work out you have 23.05 grams. Now, realistically, the answer should be 23.1 because we are only given accuracy to 1 decimal place here. So converting that to appropriate significant figures, that would be 23.1 grams.